and what the points are?
0, 11, 1, 8, and 320.
And they want what? Quadratic?
They want the particular equation.
Okay, so it's a quadratic equation, yeah?
Yes, quadratic.
So 3 points will help you find a quadratic, 4 points will help you find a cubic, 5 points will help you find a quartic.
Quartic. Yeah.
So what we're gonna do, um one way to do it is to use this equation y equals ax squared plus bx plus c, and plug in this for x and this for y 3 different times. So 11 equals, basically 11 equals c, right?
Yeah.
Can you see that 11 equals c?
Mm-hmm.
Because if you plug in 0 for x, you'll just get c. So 11 equals c, so that was good. We found 1. And so now we can rewrite the equation in like this. Whoops. Y equals ax squared plus bx plus 11. And now we just have to worry about these 2 points. So plug in for x and y for those two equations. So the first one is 8 equals a times 1 squared plus b times 1 plus 11. And the other equation would be 20 equals a times 3 squared plus b times 3 plus 11. So when we simplify those, we get, subtract 11 from both sides, we get 3, negative 3 rather, equals a plus b. And this one is going to be 9 equals 9a plus 3b. See how I did that?
Wouldn't there be a square anywhere? Oh, wait,
Oh,
no, because you're
yeah,
using
no,
that.
yep, I squared
Okay.
it. I plugged in, and that's how I got the 9. Yep. So now multiply the top equation by -1. So let's change the sign basically on all of them, and then add it straight down. So this would be 12 equals, whoops, that didn't work. I was thinking I had just an a there. I did not. So what I'm going to have to do is multiply this top equation by, let's say, -3, and put it down here below. So -3 times -3 is +9 equals -3a minus 3b. And we did that because now the b's cancel out. That's the elimination method, right? So 6a equals 18, which means a equals 3. So there's our a. So we have our c, we have our a, now we just need our b. So plug b back, or a back in to this top equation. Sorry. Plug that back into the top equation, 3, right? So -3 equals 3 plus b. Subtract 3 from both sides, b equals -6. So my equation then, I can rewrite the equation y equals, what was a?
Uh, I'm still kind of catching up here.
Oh, sorry about that. You're trying to write it as I go?
Yeah, it's fine.
So 3, you can, Vincent, I'm recording this on YouTube, so you can watch it again later and try. Maybe just watch while I do it first, try to follow,
All
and then
right.
try it on your own, and then watch the video again to make sure you did it right. That's how I would do it. So I'm rewriting it, plugging in a, b, and c into this equation. So y equals 3x squared minus 6x plus 11. And that's your equation. Okay.
Okay.
Make sense?
Yeah, I think so. I think I get it.
All right. So what's the next question you got?
Um, it says transform to vertex form by completing the square and state the vertex. Y equals 3x squared minus 24x plus 65.
Okay, so this is in standard form, and putting it in vertex form is y equals a times x minus h squared plus k. Now there's 2 ways you can do this, but they told
Yeah,
you
told you to complete the square.
they told you to complete the square. So we'll do
Mm.
it that way, but then I will show you the other way to do it as well.
All
So to
right.
complete the square, I actually like completing the square because it's not a big deal. First, factor 3 out of here because you want to get that you want to separate. Basically, you want there to be a 1 in front of the x squared. So factor whatever's in front of it, factor it out. Okay. So you see how I changed? See what I changed there? See how I rewrote that equation?
Yes.
Okay. Now what we're going to do is we're going to add something here. And we're also going to add it to we're going to also subtract it from the outside. But we're actually going to have to subtract 3 of them from the outside because
I thought that, yeah, because you have to put it back through the factor.
Yeah.
But I thought you had to bring the 65 to the other side.
No, you don't need to. No need. That's one way you can do it, but you don't need to do that. So you can leave it on that side and just subtract it. So, and the thing I'm going to put there is 1/2 of that squared. Negative 8/2.
It's 1/2. It's 1/2 of b squared. Okay.
Yep. So that would be 16. Right. So that's what I'm putting there and there. So I'm basically what I've done is I've added 16 times 3, and then I also subtracted 16 times 3 from the same side of the equation. Now, why would you do that? Well, I do that because now you can see you purposely created that so it's the perfect number so that it's a perfect square trinomial. Negative or x minus 4 squared is equal to this trinomial right here. That's what you did. So you purposely put that number there so that it would work out. And then that's plus 65 times, what is that, 48 or minus 48? 30, 48, minus 48. See what I did there? So what is 64 minus 48?
65 minus 48 is, I think, 17.
Yep, 17. So there is your equation in vertex form. So now what's your vertex? Your vertex.
417.
Perfect. And notice your multiplier is still 3. Got it?
Mm-hmm.
So that makes me wonder, oh, is there another way I could do this? Yeah, there is another way. If you can find your vertex, you already have your A, right? That's 3. So if you can only find your H and your K, then that's all you really need to do. And we can find H and K instead of by completing the square, we could find
Negative b over 2a and then put it back through the equation.
You got it. So the opposite of b is 24 over 2 times a, which that's just 4. So 4 is your vertex, or 4 is your x coordinate of your vertex, and the y.
The answer key on the answer key, they put it into they kept they kept the extra number on the other side, so they got y minus 17 equals 3, and then in the parentheses x minus 4 squared.
Okay. Well,
does that work too?
Yeah,
or?
It's the same thing. It's the same thing.
Okay.
Usually you'll see books write it like this, the vertex form, usually. But you can very easily just move the k over to the other side. That's fine too. Doesn't really matter. Okay. But getting back to this other way of doing it, if this is easier, you can just do it this way, which it probably is easier for most people, to be honest. So that equals 16 times 3, which is 48, minus 24 times 4, which is 96, plus 65, and I bet you that's 17. So there's your H, and there's your K. And now you can write the equation. Y equals, you already knew A was 3, x minus 4 squared plus 17. Or you could write it in this format. Same way.
Yep, same thing. All right, got it. Yeah. Right. So my next question is, it says graph y equals -2 parenthesis x minus 2 and the parenthesis new parenthesis x plus 5 to the 4th.
Okay. So they want you to graph this. Well,
and I already have this graphed. I just had a question about after it was graphed. So you would have a point at -5. Sorry, an x-intercept at -5, and an x-intercept at 2. and then that one would pass through because it's odd.
Mm-hmm.
And then you know that it starts at the and so it has 4 turns and the degree is 5, and it's negative, so it starts at positive infinity when x at negative infinity, so it goes up then down.
Yeah. So the negative a basically means that as x goes to infinity, f of x
F of x goes to negative
goes
infinity.
to
Yeah.
negative infinity, right?
And
And
then so
the
I have
fact
this.
that it's odd, the fact that it's odd means that they go opposite direction.
Mhm. And so I went to like the academic center during lunch to just
Yeah.
see this problem, and she had me graph it like just say this is the 2, and then this is the 5.
Uh-huh.
Oh, other way around, but yeah, you get the gist. She just had me graph it like this, and I asked her why there wasn't a bounce there, like why I wouldn't have like 4 turns anywhere. She just said that
Uh-huh.
it would have like, but she just said that it would be so small. Like the turns would be like in this little point right here. They'd be so small that you just can't see them. Oh my gosh, I'm so congested. Sorry.
Yeah, there's not really turns per se when it's um yeah, there's not turns actually. I don't think there's even turns at all.
I
It's just
just thought I
it's
just
just
thought it would,
steeper. It's just steeper is all.
I just thought it would be more like maybe like an extra bounce there.
No, definitely not. Would not do that. So the reason I wouldn't do that, that would be if there were this would represent imaginary solutions. Remember talking about imaginary solutions?
Yeah.
I that's what those would represent. When it's a multiplicity 4, it an even multiplicity, it bounces off of it. It doesn't do all kinds of crazy turns. It bounces off of it.
I just thought that like the amount of like bends that there were was just like one less than the total degree. Like that's what we were told.
That's the maximum number of bends.
Oh, right.
But it
Maximum.
but it doesn't
It
have
doesn't have to be that much.
correct. Correct.
Okay.
So if you go to Desmos, in fact, just go to Desmos,
All right.
plug that in, and you'll see and zoom in. With Desmos, I'm doing it right now on my graphing calculator, which is on my iPad. It's much better than the one on your calculator. So I'm plugging in to the 4. I'm plugging this in exactly how it is, and I'm looking at the graph, and then I'm zooming in. Whoops, I think I wrote it wrong.
Oh yeah, it just got those 2 bounces or whatever you want to call them.
Yeah.
Just come up with funny words now.
I don't know why I don't know why my graph isn't working.
But yeah, it just shows up like that.
Yeah. Anyway.
And then do you have my stuff from yesterday still?
Probably. Yeah.
I had a question on one of the problems that we did yesterday. I think it was the last one. It was like the one where the diver jumped off the thing and then went through the water and then came up after 31 feet.
Yeah. Yep. I remember that one.
Yeah, I just had like a little more of a question about that. I didn't really understand how to get the vertex still. It just
Okay.
I didn't really understand.
Let's see if I can find them. Let's see if I can find it. Whiteboards. Oh, existing. All boards. What was that date? Was that yesterday?
Yes, yesterday. It was December 16th.
Okay, hopefully it's on here. Was it one of these? Oh, there it is.
No, no.
Yeah,
Oh, Oh, these are like multiple people's things.
Yeah, there's.
Yeah, okay, that's the one.
Okay, so what was your question?
Okay. So I didn't really understand. It said to find like the where the swimmer's maximum depth was and at what distance, not just the vertex. I just
Yes.
wasn't trying to find that. I had the x-intercepts and the y-intercept, but that's
Yeah.
all I could really figure out.
Okay. Yeah, that's what they gave you, the x-intercept and the y-intercept, right?
hmm
So do you see my equation right here?
Uh, yeah, I'm just not really sure where you were going with it.
So right here, do you understand this equation? Do you see what I'm underlining?
Uh, yeah, I think so.
See my eraser? Y equals a times x minus 5 times x minus 31.
I understand where you get that from. I'm just not
Okay.
sure what to do with it. That's the
So
thing.
once I have that, what I have to do is I have to find a. I know I so if I can find a, then I can use that. This would be my equation in factored form, right? I think if there's another way to do this besides that. I mean, there is another way to do it with yeah, like what we just did. Here's another way. Maybe this would be easier for you. Do you remember how we could use those 3 points? We just did it. That point, 5 comma 0 and 31 comma 0. Remember how we just found this gives us C? So C equals
Yes.
2.5.
hmm
So then y equals ax squared plus bx plus c. We're using that equate, whoops, not c, 2.5. We're using that equation. We're plugging in 5, 0 and 31, 0. So 5, 0 would be 5.
Oh, I thought that we were plugging in the CI and the 2.5 for Y.
Well, we already did, right? We already plugged in the 2.5. Because if you
Oh, right.
plugged in 0, you'll get 2.5. That's just your C. But now I'm plugging in 0 for Y, and I get two different answers. One of the answers is, uh, I'm sorry, one of them is when I plug in 5, right? Plus 5B plus 2.5. And the other one, that's this one. And the other one is going to be 0 equals A times 31 squared plus 31B plus 2.5. And then you can go about do that same thing where you solve the system of equations. Okay.
Got it.
That would be kind of a pain though, to be honest with you, to do. The
So
other,
like try what we did before.
yeah, it totally would work to do that. In fact, if
hmm
you know how to use your calculator with vertices and stuff or with your graphing calculator, it's not hard at all. But the other way you could do it is using vertex or factored form like this. Same kind of concept, but basically what you're doing is you can take any of the points because you already have your equation. You just take any of the x and y and plug it in. And you'll get, is that right? Is that how you do? Is that all you have to do? Yeah, I think that's all you have to do. And you'll get the answer. Let's do it both ways and make sure that this is correct. So when I'm plugging in 0 and, oh yeah, that's what I'm doing. I'm plugging this point in. Yeah, 0 and 2.5, right? So when I plug in 0 for x here and here, I get -5 and -31, and then 2.5 for y. And now I can solve for a. So a equals 2.5 divided by 5 times 31. So that's
And
just
I just plugged that through my calculator, and that's just 1/62.
1 over 62.
Mm-hmm.
2.5, yeah, 2.5 is what? 5 halves. 5 halves. Yeah, so 5 halves, so the fives cancel.
So then we have Y equals 1/62, X minus 5, X minus 31. And then we just put
So now
what
we're
we
trying to find, remember the other thing you could use is the fact that this is this symmetric, right? A parabola is symmetric. So you know that this total distance here is 26, so it's 13 here. So you know that that point, that midpoint right there, the vertex is at 18. So plug in 18 for x for both of these, and then solve for y.
Right.
So that would be 13 times negative 13 times 1 over 62. And unfortunately, that doesn't simplify very well. 13 times 13 divided by 62
It
equals,
doesn't look like they got a clean answer either. It says that they got negative 2.73 feet.
yep, that's it. Negative 2, that's exactly what you get, 0.73 feet. Yep. And that's the same answer you would get if you did it this way as well. It's just maybe a little bit simpler to do it that other way. Okay, good.
Yep.
All right, Noah, how you doing, buddy? You got a question for me still? Vincent, you can stick around if you have some more questions.
Oh no, that's all I had.
All right, bud. Hey, good luck. Is your test tomorrow?
Yes.
All right, well, good luck. Have a Merry Christmas, okay?
You too. See you then.
All right, see you.
And see.
All right, Noah, what's your question, bud?
It's my question was just the barn because while I was just reviewing before I had to sleep, I remembered how he mentioned how the barn questions definitely going to be on the final. So I was trying to review for it.
So he wants to enclose a field. He has 500 feet of fencing, so that's the perimeter, right?
Mm-hmm.
But will
Yeah.
not need to fence along the barn. The barn is 50 feet long on one side of the enclosed area. So let's say that this is 50 feet. Doesn't really matter where you put the fence, but I'll make the fence red. So it's going to go like this. So he's got 500 feet of fencing with the 50-foot barn, and he wants to maximize the enclosed area. Is that what he wants to do?
Mm-hmm.
Okay, so let's say that this is X and let's say this is Y. So the perimeter equals 2Ys plus 2X's minus 50 because you don't need to fence along the barn.
Mm-hmm.
Right? And we know that was 500. So let's write our equation. Whenever you do these problems, you want to get one variable in terms of the other. So let's add 50 to both sides. 550 equals 2y plus 2x. Let's divide everything by 2 because that'll work, right?
Yeah.
So 275. Is that right?
Mm-hmm.
Equals x plus y. So that's the relationship between x and y, and we're trying to maximize the area, which is x times y. So let's solve this for one of them. Let's solve it for x. Y equals 275 minus x. So I'm going to plug this in for y now. 275 minus x, that's my area. So you can see that the area in terms of x is equal to negative x squared plus 275x, which is a parabola that opens down. So you're going to have a max point. And how do I find that max point?
Just putting into the calculator, finding the max.
Negative b over 2a. Yep, you don't need your calculator.
Negative
b all over 2a. So it's whatever 275 divided by 2 is. 137.5. 137.5 is your x coordinate of your, or is x? No, sorry. Is the x coordinate, yes. And the area, the max area, is what you get when you plug that in. So use the old store button for x in your calculator, and then type in negative x squared plus, whoops, what happened there? Negative x squared plus 275x. And you'll get the max area, which is 18,906.25. They probably asked for the dimensions, didn't they? So the dimensions, this is your x, this is one dimension, and the other one is probably the same, because isn't that just 275 divided by 2?
Yeah, it would be the same.
So it's 137.5 and 137.5.
That would be the dimensions of the
That would
barn.
be the dimensions of the rectangle that you're enclosing. The area, in case they ask, which I don't think they did in this case, but it would be that. Got it?
Yeah, that makes much more sense. And luckily, I have my math final tomorrow. Tomorrow